Hi everyone, I'm Habib Virji from Samsung. I work in Samsung in UK. So I'll be presenting you about IoT security in general. What I'm going to present is about briefly about the vulnerabilities which are there in the IoT, which have been identified in the current IoT products which are there, and then go into a bit about give a brief introduction about what the IoTivity is if somebody is not aware about it, and then go about describe about how the security in general has been addressed in the IoTivity. So just to give you a brief introduction, we have been hearing about the numbers that there are a lot of products which are going to come in the coming years in the IoT space. But the products which have been already there in the market have been identified to have some issues such as cloud issue. So it collects a lot of user-based information. The information that's sent is not having a proper security in place. And there are a lot of privacy issues. A lot of people feel that the information that's being collected is not what they want it to be collected. So based on that, I'm not going to cover about the cloud one. I'm just going to restrict it more to the local environment or to the smart home environment. In the IoT, mostly what happens is all the current IoT protocols per se, you can say, which they mostly are multicast based. Everybody can see the traffic. You want to make it more restricted to who can have a visibility to your particular resource. You don't want, for example, your smartphone to communicate with the for example, your light bulb, just an example. So you want to restrict it, you want to create a category of who wants to have access to what. So based on that, we have implemented something in IoTivity. So I'll just briefly tell about IoTivity. It's a Linux Foundation project. What it tries to, it's a RESTful architecture. That's the most important part in this one, because what it tries to do is, for example, a light bulb in IoTivity, for it is just basically a URI. So a light bulb physically it's a light bulb, but IoTivity tries to see it as a particular resource which is identified by a URI, which you try to discover using co-op mechanism. So you can get a bit more understanding about from this one. So there's a light bulb on the left-hand side, which is on the right-hand side. So it's identified as a resource, and that has a particular access control mechanism to control who has access to that. And on the other side is the OCF client, which tries to discover that particular server, and it tries to basically get the information to it, change the state of it. So that's how the whole paradigm of the IoTivity is based on. So it's primarily divided into two parts. The smaller part is the server part, which tries to basically handle the discovery of the resources. So whatever the resources that you have, it tries to do the multicast scan, which is basically advertise it, and if anybody is asking for a request, it tries to reply back to it. And then it has a small part which handles the security part of it. The security part here is, I'll be going through the different resources which are part of the IoTivity security. That will be handled on the server side. And on the other side is the client side, which is much more complex, has much more functionality, and is intended for a device like a mobile phone, just as an example, where it has much more capability. And in the security perspective, it has another functionality, which is provisioning. So the security also involves around, as I said, everything is a resource in IoTivity. So this one is security is also implemented as identifying a resource which is there, a secure resource. If it has a particular state, manipulate it and get it into the right state. So it has three steps, three mechanisms basically to support the security. One is basically the authentication, how the secure channel or the encryption is handled between the devices. and the access control mechanism, who has permission to access a particular resource. To do that, it has two steps. One is onboarding and provisioning. So I will be describing a bit more in detail about onboarding, but to get a perspective about what the device security, what I mean by device security is. So consider this as an example. You have multiple resources in multiple devices in your house. As I said, each one is considered as a different resources in the IoTivity. Now, in this one, you want to ensure that next person to your house doesn't have access to this. You want to restrict it only to the devices which you have in the house. So that's what the device security tries to do. Why we need it is OWASP, if people are aware about it, it's an organization which tries to define the web vulnerabilities, but they have also defined what are the 10 most vulnerability in the IoT. They have defined 10, so I have break it down into the category that I'm going to cover. So for the physical, so there are some poor physical security like USB, for example, there are USB ports which are accessible on the IoT devices where the information can be retrieved. And then there are like insecure cloud interface and the mobile interface. They are like basically when you try to access the cloud, the interfaces are not protected, they're not properly authenticated. Similar for mobile interface. Then there are insecure software firmware issues, like it's not properly authenticated, the firmware which is being downloaded. And the configuration is not that secure, like who has access to what when you're provisioning, that's not properly done. So the answer in the IoTivity is in terms of the onboarding. It's an important step which happens, which establish a device to a particular user. This is a one-time step which happens, which is like you bring a light bulb in your house and you want to make it a part of your network. So at that time, you try to make use of an onboarding step. So it's an isolated communication that you establish between a light bulb and provisioning tool, which could be, for an example, your mobile phone. So when you bring a device, for example, we have an implementation called as Easy Setup, where a device comes with a QR code and which you can scan it, and it's running a soft API on it. And you establish a one-to-one communication with the soft API running on the new device that you have brought. And your onboarding tool will basically provide the key, a private key, as well as the carrier key that it can use to communicate with your access point in the house, which is currently there. So onboarding mechanism can be done in 3 ways. You can do it in a manufacturer defined way also, but the OCF standard on which IoTivity is based, it defines 3: just work, random pin, and asymmetric. Just work mechanism basically works is, suppose you bring a light bulb. Light bulb doesn't have any display. So when you want to establish a secure communication with it, onboarding is, as I said, is a one-time step process which is initiated by the user. So on the onboarding tool side, which is a user having a mobile phone and having an onboarding tool on it, and on the right-hand side, we have an enrolling device. It tries to see a particular resource. So as I said, it's all based on resource. So for the security also, to get it into the state, it tries to check a particular state of a resource. And in this case is DOXM, which is basically device ownership. It tries to see if this device has been owned. This happens without any secure channel. It just checks the state of that particular device. And that device can reply back with what kind of onboarding this mechanism they support, whether random pin or just work. And then the server puts it into the state that they're going to make use of a just work, and they make a DTLS connection, which is based on using the anonymous cipher. And once this connection is established, the onboarding tool puts the private key into the new device which is being enrolled. And so please, this step is just a one-step, one-time process, which is when you have just brought your device. The security is very minimum in this. This is not advised, but it's just for devices which doesn't have a display in them. The second mechanism is random pin. It does the discovery of the state of the device in a similar way, but it uses a random pin as an extra step here. But the difference here is the enrolling device generates a random pin. So you can imagine you have brought a TV, and on a TV you want to enroll it. TV will show a pin, and that you have to enroll it into your onboarding tool, which could be a mobile phone. And when you enter that pin, it makes use of a key derivation function to generate the key, and that key is then used to establish a DTLS connection. There is a third mechanism that is supposed is asymmetric. Asymmetric can be done in two ways. One is onboarding tool is responsible for generating a self-signed certificate. The second mechanism that it can support is the manufacturer has signed the certificate, but that requires the OCF body to generate the certificate and the manufacturer having the certificate from them, and onboarding tool can then sign the certificate for the device. So this is ongoing. There are a lot of work going on this, but what it basically does is in the onboarding tool signs a certificate for the enrolling device, but the connection that's established is based on the manufacturer derived certificate. So once the devices have been done onboarding, the next step what it does is provisioning. So the onboarding main functionality was two. The first one was getting the private key. The second one was to provide a unique ID to that particular device. And then the next step happens is the provisioning to provide the information about the other devices which are there in the user network, like you were trying to enroll a light bulb. Now you have to get the information about the TV and other devices which you have. So this step ensures to provide that. So it provides you another one is the security credentials, which are the keys which you have with them. And it also provides you the access control policy, which is like who has permission to access a resource. So for example, if you have created a limitation a TV has to be accessible to your light bulb, then that kind of information is also shared. Provisioning is a continuous process. It can be either initiated by it can be initiated by a light bulb, or it can be initiated by the client itself, like the onboarding tool updates all the devices which are there in your home network about there is a new device in your network, and that needs to be, they provide the information so that they can connect with it. So how it happens is exactly like in the previous step, you have the PSTAT, which is a resource here, secure resource, and it tries to check the state of it. And based on the values over here is basically saying that whether the device has been provisioned or not. And the connection then it establishes using the key that was derived from the previous step. So the onboarding result actually resulted in a private key, which is the owner PSK key for that particular device. And the connection that's established between the device, the new device which you have brought, is going to be using that owner PSK key that was derived in the last step. And all the subsequent connection also happen using the same key, owner PSK key. So this one is basically going to push all the provisioning information about the credentials, about the access control information to the new device, about all your devices, and then it gives you basically a particular commit hash value. And this value is continuously being checked by the client and the server to check what the device information it has, and if it becomes like, if the value becomes like change, then the provisioning server keeps on updating the client. Apart from the onboarding and the provisioning, there is another thing which is there is hardware hardening. It's not something which is not mandatory, but it's kind of information which is provided to ensure that there is a lot of information which is being pushed from a onboarding tool to the new device. So new device also need to ensure that this information is stored securely. So for that, it has a secure storage mechanism that it tries to push all the devices to have. It also tries to specify about how the random number generation should be based on and cryptographic algorithm that it should support. The main idea here is that there are a lot of things which has been specified and implemented, but apart from that, there is a general kind of a guideline provided that what should be followed to ensure that the information that's shared by the provisioning tool to a new device should be securely stored. So once we have the key, it's used for, okay, I'll go more in detail about the software implementation of IoTivity. So here, how it's implemented in IoTivity is all the resources which are there are part of something called as Secure Resource Manager. It's there on both the rich device and the light device. Each has a different purpose. DOXM and PSTAT is mostly used only when you're doing onboarding. Credentials is mostly used when you're trying to get the key generation. And that's the only step where you will see CRED being used. But whenever you're trying to access the resource, it's the ACL, which is the access control list, that actually tries to handle all, whenever any request comes into place, it's the ACL which is going to check whether that particular resource has access from that device. There's a persistent storage there to handle the provisioning information about the state of each resource, so that whenever the device, if it reboots or it tries to keep it in the proper secure state to handle the device. So using the owner PSK that was generated, the next step what is there is about the connectivity, how that's used to make a secure connection between between your devices. So now there is no onboarding tool involved. It's more in between the devices which are there in your home network. So it's more of to satisfy this scenario where you have devices which are there in your home network, but if you try to access the same device from outside your home network, it should be able to access it, but the connection that is established is between a particular set of devices. So OWASP also tries to define 4 issues related to network security. Sorry. Yeah. So currently it appears that the network services which are there, they're quite insecure. There are a lot of devices sent in a plain text. So there is a lack of transport encryption. There is insecure web interface in the sense that when you try to access the cloud, the web interface is not properly authenticated and is not properly checked. And it's related, next step is related to web interface, that there is no authentication authorization each time when you try to access it. It just creates a channel and it tries to allow you to access the resource. So the secure connectivity of IoTivity tries to prevent the eavesdropping, tampering, and message replay, and it tries to make use of a DTLS. So the DTLS, it tries to encrypt packet by packet, and then it tries to also make sure that the device authentication is also checked based on the device ID using the key that it has, that it receives from the server, whether it's the same key, same device ID that it received from onboarding. So onboarding, as I said, it gives you a UID, it gives you the key. So using that, it tries to match whether the information that it's receiving on DTLS channel is from a source that it trusts. So next, moving on to the privacy. So the privacy is trying to basically just define who has access to it. You can define whether your mobile phone has an access to a TV which is there in other room, or you can try to define your thermostat can only communicate with the router, and that information should be going to your mobile phone. So you can basically manage all the information about your access, who has access to what, using the provisioning tool. So it protects all the resources at the IoTivity server. Each resource which you have has an access control entry which defines who has access, which device has an access based on the UID and what permissions they have. There can be multiple IoTivity server running on a device, and they could be logical devices. So then it can define per OCF server also. So the access control policy that it defines is per group, per device, per resource, and property. And it's like on an overall layer, it tries to define at most granular level, you can define at the property level the ACL policies. So in terms of the access control, you can basically check whether the light is on, and if you have a permission to read, you get the response back. But if you try to send a request like turn the light off and you don't have a right permission on it, it's going to reject the permission to it. So that's what access control is trying to do. There is another mechanism which is provided, is AMS. AMS is basically for remotely you can delegate the access control handling. So you can imagine the light bulb is quite small. It can't handle all the access control requests. So it can delegate to AMS, and AMS tries to say that this resource has an access, and then the light bulb will allow the device to have an access. It creates an extra step, but it's more or less for devices. If you have a big network, you can't handle it, then you can make use of AMS. So to conclude, so there are the few OWASP issues which I showed in the starting. I've been going through them, and there are some solutions which IoTivity currently provides. So some are in terms of the hardware hardening. It's more based on guidelines that you can make use of, and there's some issue, some solution has been directly provided for cloud interface, mobile interface, and web interface. You can make use of, for example, if you're trying to access the cloud interface in IoTivity, you can make use of a user authentication and CoAP over TCP, which has been recently introduced. And it tries to still make use of the same secure channel which you use in local environment, also in the remote environment, and it tries to make use of the same private key to create a secure channel between the device. The insecure firmware issue, which has been, which is a very important one. It's not currently addressed, but it's in the pipeline to get have some solution for it. The configuration is handled by the provisioning. So provisioning is handling which device has an access to it, which access control list has a permission to access which device. And lack of transport encryption has been addressed by having a DTLS, and so it's more as a transport layer rather than an application at the moment. But it might be, there are some discussion on it to have an application, but it could be but to handle a more bigger scenario. And there is insufficient authentication and authorization. So that's handled by having multiple steps, like having a DTLS connection, having a PSCN certificate, and also an access control list to it. So thank you, and if you have any questions, yeah. Your question is basically, is smart thing able to talk to IoTivity, right? My understanding is that it does have a support for IoTivity, right? Yeah. Yeah.
How do you handle the revocation of
Yeah, so the question was basically how the revocation is being done. So if you have the done using the symmetric mechanism with the just works and random pin support, then you have to basically delete that information from the onboarding tool, and it updates all the provisioning devices.
Manually?
I beg your pardon?
This is done manually?
Right now, the solution which exists is basically you have to go to your onboarding tool and do it. So you can initiate that process. Or the second mechanism is for the asymmetric, there is a certificate revocation list. It's supposed CRL mechanism, so it allows you to, if you revoke a particular device, it's going to update all the device with that CRL information, and that device will be invalidated. But does it happen? You have to initiate it manually. It cannot happen automatically. It cannot identify, for example, your device is not part of your network now. So you have to do it manually.
How about device replacement or upgrade? Do I again have to repeat the whole onboarding, remove it manually again?
So if you do, for example, firmware update, you mean to say?
Like for example, the device failed and I just replace it with another device. It can happen in the field. So
Yeah, then you will have to do onboarding again. So for yeah, because the onboarding step generates a unique ID based on a MAC address and the other information of the device. So it will be based on per device basis. Yes.
There is these standards-based authorization like OAuth 2 and so on that's available as shop and such. Are these very nationally again, standard-based protocol? Any investigation using those?
Your question is, do we make use of OAuth mechanism to? No, currently there is OAuth mechanism not supported. As such, the OCF standard doesn't try to make use of a user, like it's a device belonging to a particular user. It's more based on device to device communication based mechanism. But there are new implementation for the cloud that tries to introduce a user concept into it. And when you so what it tries to do is you can log in to a particular OAuth providing server like Facebook, or and there that particular device which has an access to it using the OAuth token, you can access a particular device. So there's some work being done, but it's more at the moment it's not part of the OCF standard. It's more of a implementation which is there currently. Any other questions? Yeah.
can you explain why a device can have only one owner?
The main idea at the starting was not to have a user authentication mechanism, because as soon as you start bringing the user, then the next step would be how do we handle the next user which is there, how do we pass on the provisioning information to the next user. So that's why I said it's more tied up to the device at the moment. But having said that, now there is a lot of thing that's going on to have a group communication. How do we, so for example, if I'm making use of my mobile phone as an onboarding tool, and it becomes I carry it all around, so it becomes quite a risky thing, right? So the step is basically how do we move it to the other device, whether the cloud has to be involved in it. If you were there in yesterday's presentation, Vijay talked about if you're there at other place and your wife want to have an access to a particular thing, how do we pass the information via cloud to the other owner? So it's the group as such has not been introduced in IoTivity as such, because it makes use of a DTLS which also kind of restricts you to the group communication. So the group scenario has as such been not implemented, but it's something which is under discussion. So might be in IoTivity 2.0 there might be some implementation for it. But right now the issue is known, but the solution as such doesn't exist at the moment.
My use case is not being like two users owning a device, but two service providers having access to an actuator, for instance.
You can make use of provisioning. If it's a device, then you can, so when the onboarding tool, which it makes the isolated communication, is just for onboarding, but the next time the communication that happen, it can happen between any device, because that's what provisioning is doing. So provisioning is ensuring that your TV can speak to light bulb, your mobile phone can speak to air conditioner. So it's going to allow you to speak to any device. So you can, if you want to speak to two devices, you can make use of provisioning to do that. Yeah.
Is Samsung already applying those smart devices that Samsung is producing today for smartphones? Security infrastructure.
This is there, so it's there in IoTivity as such. So the provisioning and the there is a, as I said, there is an implementation easy setup which tries to take care of it. So there is something built on top of the provisioning. So what it does is you can bring a device, and it will have the soft AP information. You can scan it and connect to it, and onboarding will be done using that that communication, the isolated communication. It does the provisioning for you, and once that step is done, you speak to all the devices in your home network. So that's the idea of the easy setup, and it currently works only on Wi-Fi.
So, for example, if we take the example of the smart TV,
Yeah.
a lot of smart TVs.
Yeah.
All those right now can support this onboarding process as well as the security association, all these kind of things.
I'm not sure about the products, so I can't really say. Yeah. Any other questions? Yeah.
Onboarding tool and stores this information about the devices on the phone itself, right?
Yeah.
Everything is on the phone.
It is just an example. I said that onboarding tool, it can be a mobile phone, it can be any other device also. It,
Is there a backup solution for this?
exactly, yeah, there has to be a backup solution. So right now, there's nothing as such defined and implemented. So it's more or less tied to one device at the moment. So there is a discussion to have facility to transfer the information from mobile phone to any other device that we think is secure. So probably if you want it to be on, for example, on router. Just an example, router is quite vulnerable, so you don't want to have that over there. But just an example. So there, right now the transfer mechanism doesn't exist, but it's something that we want to address it.
If this mechanism doesn't exist today, what happens if somebody loses the tool? I mean, all those devices deployed in the home,
Yeah, they become vulnerable.
going to be isolated by themselves forever, or can you erase their settings?
There is a mechanism to do it, but it has to be based on the, right now it's tied to the provisioning tool as such. So if you lose the provisioning tool as such at the moment, it's an issue. But as I said, it's a known issue, and we are trying to address that you can transfer it to another device, or you have some backup mechanism to ensure that. But as such, we haven't defined it at the moment. Yep.
One question that during the onboarding, if the device has already a device ID, that is changed, right?
Yeah.
So can you do, if it wasn't about changing it, the purpose is pretty much simple. So is it so that you don't trust that the device maker has a unique device ID origin when the device was made?
Sorry. The idea is that since all your security that's going to be provided is via onboarding tool. So onboarding tool is kind of the one that's going to it's responsible for getting the device ID. As such, if you see currently also in the platform in IoTivity, it cannot have the device ID on its own. It tries to rely on the provisioning, it relies on the onboarding step to get that. So the security stack as such is the one that's responsible for generating the device ID. So when you're trying to onboard, the device ID which is being generated is the one that makes it introduced by the provisioning tool. You don't want to have the one that's there on the device. So you bring a device, you have an onboarded, somebody has that device ID information.
I
Yeah.
thought that it was easier to test devices than testing applications. Like provisioning tool and OBT, they can be network management consoles or can be applications on your mobile phone. So how are you going to make sure that every OBT app there complies with the specification?
Yeah, I think that will be a challenge. So right now what is there is it's part of the IoTivity which tries to implement that, right? So it's currently, yeah, they have to have some mechanism. So for example, in the asymmetric model, the onboarding tool has to be signed by the certificate from the OCF so that it can be able to sign the other ones. So the onboarding tool needs to have. So for example, if each manufacturer has a different onboarding mechanism, which there is a support for that, but if they do, all the onboarding tools will need to have a support for that. So onboarding tool, I think so, will have to be kind of open source as it is right now in IoTivity to handle the different scenarios. Any other questions? Thanks for coming.